My name is Siddhartha Natarajan. This project is based on human activity recognition by aerial robots. The purpose of this project is to demonstrate that it is possible to identify human actions from a top-down camera angle. The project will aim to investigate if it is possible to use a YOLO v3 network that is purely trained on synthetic data. There are many applications where a top-down camera angle would be useful. Some examples would be security, surveillance, search and rescue operations. The project must meet the following requirements: to 3D model realistic scenes and human characters, to fully label the rendered frames, to train YOLO v3 using a custom dataset, to test the neural network on both real and synthetic images, and then note the findings. The custom dataset has 4 action classes which can be seen on the right. It also includes 4 actors, has a high dynamic range background, has random and abrupt camera motion to simulate the UAV, has top-down view, and multi-labeled subjects. Once the 3D modeling program has rendered all frames, it would then be imported into Microsoft VOTT. In here, each frame will be labeled individually. It would then be outputted as a CSV file, which can be seen on the left. The CSV file will then be converted into the YOLO format using a Python script, which can now be seen on the right. Here are some examples of the 3D models that were created in order to make this project. On the left is an example of a male human. The middle image shows the HDRI lighting the background. The image on the right shows a top-down angle for one of the scenes. Once the custom data set has been used to train the YOLO v3 network, it can then be used to test images. On the left is a snippet of the Okutama dataset. On the right is an image from Google. While testing the YOLO v3 network, there are a few issues that were found. One was confusion between standing and walking. This is because for a brief moment when the 2 legs cross, it looks like the model is standing. There is also an issue of misidentification. Both of these issues can be remedied by giving more training, by using more images. Now I will briefly show you the 3D model, and then we will look at the YOLO v3 demonstration. Here you can see a fully rendered 3D model. This is a live render, which means it is interactable. You can see there are several humans walking here. There's one here and one here. You can see the background is made out of a HDRI, and the HDRI would interact with the lighting environment to produce realistic shadows. There is also a sun, which is used to generate the harsher shadows. Everything is designed using the PBR system, which generates physically accurate renders and physically accurate textures. Now moving on to the YOLO v3. As you can see here, we enter the data folder, and then the source images folder, and then the training images folder. In here, all of the files are stored for training the YOLO v3 network. Here we can see the test images. There are 10 real images and 10 synthetic images, which belong to a scene that was not part of the training. When we run the YOLO program, we can see how the neural network will identify humans within each image and try to classify them. First, we need to change our directory to go towards the detector Python script. Now we run the Python script called detector. The file will now execute. Depending on if you have access to a GPU, it will execute with a slightly different time. We can now see our test information inside the test image detection file. A CSV file will be generated alongside of the images. We can see here that it has successfully identified 2 people as walking. Another image where it has successfully identified someone is standing up. It is also possible to test video. An example has been done before. The video can be seen where the Okutama data has been tested. With further training, it can be improved. In conclusion, we can ascertain that it is possible to train using purely synthetic data and deploy it in a real-world situation, given enough training. Thank you very much for listening.